Thank you, everyone. Today, I'll be presenting our paper on evaluating the benefits of explicit and semi-automatic clusters for immersive sensemaking. My name is Ibrahim, and my co-authors here Leah Lai, Kylie Davidson, Dr. Chris Knott, and Dr. Doug Berman. Before we start, let's get an understanding of sensemaking. In sensemaking, we are given a bunch of raw data and some questions to answer. Our job is to browse through this data, identify the relevant information that might help us answer those questions, extract those information, organize them in an orderly manner, and finally present the big finding, a meaningful insight that helps us make sense of the raw data. A common example of sense-making task is a private detective solving a crime. A more formal representation of this process was offered by Pirelli and Curd in their sense-making loop. As you can see here, the more effort you give, the more structured your data becomes. This whole process can be complicated, time-consuming, and cognitively stressful. What if we could reduce some of the stress by having the machine work side by side with the analyst to structure their data? Maybe the machine could perform some of the more mundane recurring tasks for the analyst, sparing them to spend more time to think. We observed analysts working on an immersive visual analytic system, and we noticed that the analysts spent a lot of time creating schema by organizing the documents. And there's a pattern to their actions that could be replicated. Even when the analysts are working on a 3D environment, we have observed them to create 2D groups of documents. By having these groups in environment, help them unload some of their mental hypotheses. Instead of seeing 50 individual documents all scattered, they were concerned about maybe 5 groups of documents that were organized based on some theme. What if the machine could help to make this easier? There are 2 ways the machine can facilitate the cluster interactions in sensemaking. First, the machine could add explicit boundary around the cluster so that the analyst's mental model gets a more concrete form. In addition, they could also interact with the cluster as a unit. Second, the system could extend that feature and spare the analyst from creating the cluster altogether. It could observe the analyst's action, keep track of the document's positions, and anticipate when a group of documents represents a cluster. But would that help the analyst or distract them? To be more specific, exactly how much automation would the analyst actually need? We developed a pilot study where our application was fully autonomous in creating clusters for the users. For example, in this case on the right, the algorithm would create 2 clusters like this. Let's say the user adds another document here. The system will then update the clusters like this and reorganize the layout in a way that may deviate from the user's intent. This made the users confused, and they spent more time on fixing the clusters rather than the actual sense-making process. Through several reiterative sessions, we decided that the clusters assistance tool we are planning to develop need only help at the beginning for creating the clusters. After that, all the cluster-related interactions can be accomplished by the user. That prompted us to create a semi-automated clustering technique called proximity, where the system would take care of the creation of the cluster based on the positions of the nearby documents. Naturally, in 3D layouts, the participants can make clusters of differing shapes and densities, so we cannot rely on simple boundary threshold to identify the cluster. Rather, we need an algorithm that can detect arbitrarily shaped clusters of different densities. We applied the Bayesian-Gaussian mixture model for that purpose. To compare the effectiveness of the semi-automation, we also had a condition that was fully user-controlled. The user could create the cluster by overlapping 2 documents with each other. Finally, we also had a control condition with no cluster interaction whatsoever. Other cluster interactions included the users could expand the cluster by adding documents to an existing cluster. The user could also remove the cluster by moving documents away one by one. The user could also merge 2 clusters to create one bigger cluster. We had two research questions regarding the experiment. The first question seeks to answer the effectiveness of the explicit clusters. The second question seeks to answer the effectiveness of the semi-automation in the immersive system. We planned a user study to answer these research questions. We had 27 participants. We had 3 sets of datasets with 30 images on each dataset, and those datasets contained images and names of foods, animals, and vehicles, as you can see here. Overall, the user's task was to organize an exhibition space with the given images of the dataset. Now let's come to the results. We measured the interaction velocity as the distance per second that the user moves the document. We collected more than 2,000 data points from our participants for each session. We found that the participants are faster in the semi-automated condition, but not so much in the user control condition. Upon further examination, we discovered that in the user control condition, the users were only slow in the first session. In the second session of the experiment, they started getting faster. So that only partially supported our hypothesis that explicit clusters would make analysts faster. Our second hypothesis was that explicit clusters would speed up the process of reorganizing the workspace. We plotted the cluster movement time against the cluster size and found out, as expected, cluster movement time stays constant for both overlap and proximity, but it increases with the number of documents in cluster in the physical condition, as they had to move individual documents one by one. We also noticed that the users tended to create bigger clusters in the conditions where they had access to explicit clusters. Because of the ease and comfort it offered, the users ended up creating bigger clusters. Our third hypothesis was explicit clusters would make the final layouts less ambiguous. To test that, we calculated the silhouette scores for the condition. The silhouette score, the lower the silhouette score, it means that the more compact the environment is, and there are more overlaps, and the higher the silhouette scores are, the clusters or the groups are more distinct and they are more scattered in the environment. Comparing the silhouette scores, we found out that the users used a much tighter space in the two conditions where there were explicit clusters, meaning there were more overlaps between multiple clusters. But that did not bother the users, as the clusters were wrapped around with explicit boundaries. So that the explicit clusters did indeed make the final layouts less ambiguous for the users. Another hypothesis that we started with was that the users would prefer having more control over their clusters, which was not supported. 75% of the participants ended up choosing the semi-automated condition over the user control condition. As a reason, they found the semi-automated condition as easy as the freestyle. Moreover, they also found it to be quicker approach. Still, 75% is not an overwhelming number. So what happened to the other conditions? We asked for the user preferences on the other conditions. We found that there were a few participants who were just frustrated with the semi-automated technique because their output kept getting deviated from their intent, making them work extra to fix the layouts. Their frustration was reiterated in other participants who just preferred having full control over their workspace. Even freestyle was chosen by few participants who just liked the level of creativity they offered. For example, one participant created a subcluster inside a bigger cluster, which was not possible with the other two conditions with explicit clusters. And finally, the key takeaways from our experiment is that we found out that having explicit clusters in the immersive space improved user interaction efficiency. Semi-automated clusters did make things easier, but they lacked the control that the user wanted. So the future work should look into improving this semi-automated technique with better control and offering more creativity to the analyst. Future work should also involve some other semi-automated features, such as auto-labeling, subclusters, auto-alignment. With that, I conclude my presentation. Thank you.